This is another Higgs video. This is Dilepton mode heavy top quark Higgs boson high transverse energy jets ZEUS HERA 1. This is a video of 6 videos, so you'll have HERA 1, 2, 3, 4, 5, 6 plus a bunch of keywords, okay? So they're all together, they've been divided up into 6 components. Yeah, 6. So September 9, 2012 is when I was working on the WOW data. Today's September 29th. So Google Dilepton, and up comes this PDF file from 1993. It says heavy top quark searches in the Dilepton mode at the Fermilab Tevatron. That's from Teohan and Stephen Park from Batavia, Illinois. And they're from Fermi. So we present the results, and this is a quote, we present the results of a detailed study of the effects of B tagging on the heavy top quark signal and backgrounds for the modes of the Dilepton plus 2 high transverse energy jets at the Fermilab Tevatron. The general characteristics of the heavy top quark signal events are also discussed so that a comparison can be made between B tagging and imposing stringent kinematical cuts to eliminate backgrounds. 1993. And that's link.aps.org and then prl.aps.org. 2 different reference numbers. So I'm going to Google high transverse energy jets ZEUS to see what comes up, and here's a quote. Setting the jet energy scale for the ZEUS calorimeter and wing on behalf of the ZEUS collaboration, June 2012. This is a quote. A much improved determination of the transverse energy of jets has been carried out in ZEUS, using a correction procedure based on 2 independent methods. The first is based on a combination of tracking and calorimeter information, which optimizes the resolution of the reconstructed kinematic variables. The conservation of energy and momentum in neutral current deep inelastic EP scattering events is exploited to determine the energy corrections by balancing the kinematic qualities of the scattered positron with those of the hadronic final state. The method has been independently applied to data in simulated events. The second method uses calorimeter cells as inputs to the jet algorithm. Simulated events are then used to provide a correction for the energy loss due to inactive material in front of the calorimeter. A detailed comparison of the jet transverse energy and the transverse energy of tracks in a cone around the jet provides the final correction. This procedure relies on an accurate simulation of charged tracks and so is less reliant on simulating the energy loss of neutral particles in inactive material. Final comparisons of the data in simulated events for both methods allow an uncertainty plus minus 1% to be assigned to the jet energy scale. They went to a conference on calorimetry in high energy physics at Caltech, Pasadena in March 2002. So there's the site number for that. Matthew Wing, and there's the link there. Okay. September 9th, formula idea. Dilepton mode plus heavy top plus quark plus 2 plus high transverse energy plus jets. Google. Sorry, never mind the Google. I was Googling it to see what it meant, which is going to go in the next video, just so you know. Anytime I Google stuff, I stick it in the next video so we can look at what it means and what it has to do with this stuff. Fermilab Tevatron, heavy top quark signal events plus B tagging, plus kinematical cuts plus eliminate plus backgrounds, plus transverse energy of jets plus ZEUS, plus tracking plus calorimeter plus optimises plus resolution, plus reconstructed kinematic variables, plus conservation plus energy plus momentum plus neutral plus inelastic plus EP scattering events, plus the energy plus balancing, plus kinematic quantities of scattered positron plus hadronic final state, plus calorimeter cells plus inputs, plus jet algorithm, plus correction, plus energy loss, plus inactive material in front of the calorimeter, plus the comparison, plus jet transverse energy, plus transverse energy of tracks in a cone around the jet, plus final correction, plus the charged tracks, plus energy loss, plus neutral particles, plus inactive material, dark matter, plus the final comparisons, data, simulated advance, both methods, uncertainty plus minus 1%, assigned jet energy scale. Google ZEUS collaboration comes up. Tuesday, June 12, 2012. This is very recent. So, measurement of isolated photons accompanied by jets and deep inelastic EP scattering. The production of isolated high-energy photons accompanied by jets has been measured in deep inelastic EP scattering with the ZEUS detector at HERA, H-E-R-A. Using an integrated luminosity of 326 pb minus 1, measurements were made for exchanged photon virtualities Q2 in the range of 10 to 350 GeV2. The photons were measured in the transverse energy and pseudo-rapidity ranges of 4 less than ET. Ugh, I don't know how to read this stuff. Gamma less than 15 GeV and minus 0.7. Forget it. Hey, you guys read it. It's easier. And the jets were measured in the transverse energy and pseudo-rapidity ranges of 2.5. All that stuff there. There we go. I don't feel like trying to figure it out. Differential cross sections are presented as functions of these quantities. Perturbative QCD. That's a keyword. QCD comes up a lot. Predictions give a reasonable description of the shape of the measured cross sections over most of the kinematic range, but the absolute normalization is typically in disagreement by 20 to 30%. So there's the original documentation on that link, and here's the cpr-hepex.blogspot.ca. That's where I found it. Okay? Thank you very much for blogging that. My thoughts. Google keywords in the next video's blog posts. So these are in the next videos, these are the words I'm going to look at. Calorimeter, reconstructed kinematic variables, EP scattering events, transverse energy of tracks in a cone around the jet, jet energy scale, B tagging, and I'm going to study more of the keywords from this data in the next 2 videos. Actually, there's more than 2. 1, 2, 3. There's 1, 2, 3, 4, 5 more videos. I better change that to 5, right? I only had 2 more when I did it, but then, of course, there was more, right? There's always more. It never stops. Okay, so that's the end of that video. I'm going to go on to the next Higgs video, okay? Thank you for watching.